Hello everyone, and welcome to my electron configuration of ions lesson. We're going to be talking a little bit more about how we get the, cations and anions in our ionic compound by focusing on their electron configurations, both for the S and P block as well as the transition metal, and I have a quick practice for you as well. Okay, so as you probably remember, the energetics of the ionic bond formation that we had in our previous lecture explains why many of the ions are trying to adapt the noble gas configurations. For example, if you're looking at sodium, we said that sodium is going to lose only one electron, right? No more than that, because we are reaching to our neon noble gas configuration, right? Now, if you think about the energy, the lattice energy, right, and the potential that we have between the cation and anion, we said that if we have more charges, we're going to have a stronger forces between them, right? So it seems that if I have like sodium with 2 plus, right, because we have higher charges, that would be, that would be making a stronger ionic interaction, right? But that is not going to happen because the removal of the second electron, which is the second ionization energy for sodium, requires a massive amount of energy, and that is not going to be feasible, right? And that's why we are going to stay with only one positive charge, only sodium plus, and sodium 2 plus does not exist, right? So similarly, for the nonmetals, adding electrons to them is energetically favorable if we add that to their valence shell, right? So for example, for chlorine, we said that it is so easy to make it as chloride because we have high electron affinity. And when you're looking at the electron configuration, we actually can see that we are catching argon. We're reaching to the argon configuration, right? So formation of chloride with 2 negative charge, right? That anion requires adding another electron to a higher shell, which is not going to be favorable, right? And therefore the, Cl with 2 negative charge does not exist, right? So generally speaking, for the ionic compounds, typically we have, +1, +2, and +3 for the cations of group 1, group 2, and group 13. And then -3, -2, and -1 for the anions of the group 15, 16, and 17, the nonmetals, right? So this is pretty much based on their electron configuration and achieving to the octet shell, right? Okay, so as we said in our ionization discussion, right, if you remember, for the ionization energies, we always have like increasing in the energy very rapidly as we progress, right? So the lattice energies of ionic compounds are usually large enough to compensate for the loss of up to 3 electrons, not more than that, right? This explains why the cations with charges of, +1, +2, and +3 are commonly found in an ionic compound, right? Now, the story is going to be different when you're looking at your transition metals. They often have more than 3 electrons beyond the noble gas configuration. For example, if you're looking at silver, typically we have it in a form of silver plus, right? And if you look at their electron configuration, for silver, I have 5s1, 4d10 on the valence shell, right? And if you try to turn that to silver plus, we need to remove an electron from the highest energy shell, which is going to be the 5s. So that is going to be our valence shell, right? So I'm going to take that one out, and now I have 4d10, which is a closed shell configuration, right? Okay, so in summary, for our transition metals, generally they do not form the ions with the noble gas configurations, right? If you need to make cations for these transition metals, which is pretty common, we need to take the electron from the S subshell first. And if you're done with that and you need to take more electrons, then you can go ahead with your D electrons, right? So here is an example for ion 2. I'm going to start removing electron from the 4s. So the 4s2 electrons are gone, and I have 3d6. And if I want to make ion 3, then I need to remove another electron, and that must be from the 3d shell, right? And that would give me 3d5. And always keep that in mind, the octet rule, while it's pretty useful for the S and P blocks, we're not going to use that for the transition metals, okay? Nicely done. So that brings us to our practice. So here's the question. Which combination of the elements gives an ionic compound? Okay, so think about it. If I have hydrogen and chlorine, they both are nonmetals, so they're going to give me not an ionic compound, right? This would be just a covalent bond, so that's not the case. If you're looking at calcium and bromide, yes, you've got calcium, which is a metal, bromine is a non-metal. Yes, they're going to have transferring of the electron, right? They're going to make calcium bromide. Yes, that must be the answer. If you're looking at the S, sulfur and fluorine, right? They both are nonmetals, so they're going to make covalent bonding. So the final answer must be answer choice B. Excellent. Thank you so much for watching this video. If you like it, please give it a thumbs up. If you have any questions, you can always comment it below. There are going to be a lot more coming up soon for you. I'll see you then. Take care of yourself for now. Bye bye. Have a great day, everybody.